Hello everyone, and welcome to this Embarcadero Technologies webinar presentation, Creating Windows and Mac OS X Applications from a Single Code Base. Thank you so much for joining us today. My name is Christine Ellis, and I'm your GoToWebinar organizer for today's event. Joining me today is John Thomas, Director of Product Management for Embarcadero, and Dan Wahlin, Microsoft MVP. I'd like to begin today's presentation with a basic overview of the GoToWebinar software we're using. To view the meeting control panel, locate the orange arrow at the top right corner of your screen to show Control Panel. To ask a question, locate the Questions area on the GoToWebinar control panel and type your questions into the box. Your connection at GoToWebinar is muted, so the only way to facilitate questions is through this dialog box. Please feel free to submit your questions at any time. You can view the presentation in full screen mode. To switch to full screen, click the round blue button on the corner of your control panel to toggle between full screen and window view. All audio during this webinar is presented using voice over IP streaming audio on your computer. There is no telephone dial-in number for the event. Today's presentation will be recorded, so if you miss any part of the presentation, you can go to the events page on the Embarcadero website within the next week to view it. We'll also send an email out to everyone who is registered for the webinar with a link to the replay when it becomes available. Please hold on one moment while we start our recordings. Welcome to today's webinar. You're joining us for Creating Windows and Mac OS X Applications from a Single Code Base. Our presenters today are Dan Wahlin and John Thomas. Dan Wahlin founded the Wahlin Group, which specializes in .NET, HTML5, jQuery, ASP.NET, and SharePoint consulting, as well as on-site and online training solutions. He's a Microsoft Regional Director and has been awarded Microsoft's MVP Award for ASP.NET, Connected Systems, and Silverlight. Dan is on the iNeta Speakers Bureau, speaks at conferences and user groups around the world, and has written several books. Dan blogs and writes regular columns for different technical magazines. JT Thomas is the Director of Product Management for RAD Tools at Embarcadero Technologies. I'd now like to hand things over to today's experts, Dan and JT.
All right, well, I'm excited to be here. My name is Dan Wahlin, as mentioned, and I run a company based in Phoenix, Arizona called the Wahlin Group, and we do a lot with companies throughout the world when it comes to desktop and web applications, and that's what we're going to talk about today, some of the challenges that are now coming into the enterprise. I'm going to introduce things and kick it off, and then I'm going to turn things over to JT Thomas, who's going to take over from there and show some really cool demos of what can be done to target both Windows and Macintosh with your applications. So the agenda is I'm going to start off by talking about some of the OS adoption rates, and I don't think there'll be any surprises here on how well Windows is still doing and how Macintosh is actually catching up somewhat, though. You can go into a boardroom in just about any meeting of any company, depending on the policy that is, and you'll start to see a lot of mixing going on between the different alternatives. Once we talk about kind of how the adoption rates are going, which will be pretty quick, I'm going to jump into some of the challenges that, whether you're a manager or a developer on a team, that you're going to run into as we deal with writing C++ apps or other apps that need to target not only Windows, but also Macintosh. And we'll talk about some of the challenges there. And then I'm going to turn things over to JT, who will show some pretty cool demos of what we can do to help solve those challenges. So let's jump into adoption rates. So I pulled some stats from 2009 through 2011, up through basically December of last year. And you can see that Windows is still dominating overall, and Mac is about 5.37% overall. Now that's actually up, though. If you look in past years, you'll see a steady increase. In fact, if you just look at Q1 of 2012, the number as of end of March, beginning of April of this year is 6.58%. And while I'm not really big into the stats because they always joke that 80% of all stats are made up on the fly, but these are pulled from a credible source. And what I go by, though, is what are my customers saying? And I was out in New York City about a month ago and actually had a client ask me about what are you doing to target Macintosh and Windows, because we're now having this kind of debate coming up in the company, whereas before they didn't have to worry about it. Now, if we move forward and break it down, here's kind of the breakdown on the Mac OS as far as 10.5, 10.6, and then if we go into Q1 of this year, you can see 10.7 showing up. and we're at about 2.22% on that. But the bottom line is these numbers are steadily increasing, and like I said, I'm not one that so much hangs on the numbers as what I see in real life, and I think we're all seeing more and more of this, depending on your company's policies, of course, within the enterprise. And I think it's just going to get bigger, especially as all these college students continue to hit the job market. Now, what are the challenges that we run into as a manager of an IT team or as a dev on an IT team when it comes to building apps that work not only on Windows but also on Macintosh? And it turns out that it's certainly feasible. It's very possible if you already know .NET or C++ or whatever you're using for Windows, you could certainly learn the other technologies to move to the Apple platforms and frameworks and things. The challenges I'm going to talk about, though, are the more long-term things that we'll run into, and if you've been in development long, you'll probably identify with these. So first off, learning a language and the patterns that go along with the languages, I personally think there is a little bit of a hump you have to get over there, for instance, between Objective-C and C# and C++, but it's not insurmountable. Syntax is syntax, and once you learn the language, personally, I don't think it's that bad. The patterns, fortunately, are global patterns. They're not really unique to any framework per se. And so while that is a little bit of a hump, especially maybe for some employees that only have one or two specialties, it's something it's not insurmountable. For me, the big challenge is always the frameworks, because I can learn the syntax, but knowing how to use the framework and when I'm supposed to write custom code versus call into code that's already provided for me by, in this case, Apple or Microsoft, that could be challenging. I remember back in the day when I first learned Java, the language syntax wasn't very hard because I already done some C-based languages. The challenge was understanding the packages and all the frameworks I wanted to go into, and then the same thing happened with a move to .NET for me. Same thing I think goes for the Cocoa framework for Macintosh if you haven't dealt that before. Now, the other thing that comes up, of course, is the IDEs that we use. You might be using Visual Studio or a C++ tool or Eclipse or whatever it may be. Well, that's going to change, of course, on the Apple platform because they have a very specific Xcode tool that we'll be talking about a little later here. That gets us down to the end of it, which, if you really sum it all up, is we need a different set of overall skills. And while it's not insurmountable, as I mentioned, I think the challenge is if you're already strapped for developer resources and getting that productivity out of the developers, well, maintaining two code bases and having expertise in both sides, both frameworks on Windows and Apple, Objective-C versus C++, C#, VB.NET, whatever it may be on Windows, that's where I think it really long-term is a little bit of a challenge, especially if you're a manager and you're going to have turnover from time to time and you lose some of the skill sets you might have had. So as I mentioned, with the Apple framework, if you haven't looked much into it, you'll be writing Objective-C code if you want to target it natively. And they actually enforce a pattern, which I like a lot, the Model View Controller pattern, which provides a really nice separation of your interface from your implementation. I like to do that anyway on Windows, although with a lot of the stuff with Windows, you really don't have to go down that route. But I'm a pretty big fan of that pattern, so it's something that I think is good anyway. If you jump down to Windows, then we have a lot more language choice. We can do C++, C#, Delphi, Python, VB, and so on and so forth to target native Windows applications. Now, of course, there's various patterns you can pick, ranging from MVC, which is certainly possible to do. You could do MVP, and there's all kinds of other repository and all those types of patterns behind the scenes for data access and business rules and things along those lines. I think one of the big things on the Windows framework is out of the box, you're really not required to choose a pattern. If you're happy on a Windows form app, mixing all of your C++ or C# code right into it, into the interface, then it works. Of course, it's not great for reuse, but it works. Whereas on the Apple framework, you're kind of driven down a little cleaner separation route. And in that regard, I kind of like that. Very nice. But that's the challenges we have as a developer is, okay, what are we going to do? Are we going to learn both of these, or are we going to pick one and go with it? Now here's just a really small code snippet. If you really haven't looked at Objective-C before, It is a C-based language, thus the name Objective-C. And then we have a C++ demonstration down here. Now, if you're coming from a C background, whether it's C, C++, C#, Java, something like that, I think the code down here looks pretty familiar to you. You know, we create a new type, we access a member, method in this case, we pass a parameter, and then we do some cleanup here. Well, in the Objective-C, I know the first time I saw it was a little bit unique, I guess is the word, because the member access is quite a bit different. You'll notice that we have the square brackets here on both sides. So in this case, jumping down to here, we create a type here with the myType variable. Then we're going to call into myType instance method, whatever that name is, and pass this parameter of 10, just like we do down here. So as I mentioned earlier, it's not like you can't learn the syntax. Obviously, if you've learned multiple languages over the years, that's pretty normal. For me, though, the challenge isn't even the syntax. It's, if we move forward, the frameworks. With Apple, we're going to have the Cocoa framework, whereas with Windows, we have quite a few different frameworks. Everything from .NET, Windows 8 is going to have the new Windows Runtime or WinRT to build Metro apps. We have the old COM-based approach. And then, of course, if you're doing, for instance, .NET, want to invoke native APIs, you could do pinvoke and those types of things. So even if you learn the syntax, I think the challenge now becomes, does everybody on the team understand the difference between these different frameworks, especially if you want the same exact app to run on both Macintosh and on Windows? And that's, for me, what the big challenge is learning that. Now, the other thing that will come up is the IDEs that you'll be using. As mentioned, if you're going to be working on the Macintosh environment, and if you've done this, you've probably seen it before, but we have Xcode, the interface builder tool. And in this example, I have a couple buttons, and we can wire those up to events over here to the right. I have kind of a drill down of the different objects on my UI over here to the left, and I can get information down here. So pretty standard layout, whether you've used Visual Studio, Eclipse, or Xcode. But obviously with any IDE, learning your way around that can be a little bit challenging. You know, in the perfect world, it'd be nice if we could just use Xcode on both, or Visual Studio on both, or some type of Eclipse on both to build these types of apps that are native. In reality, though, if you want to build native with Objective-C or C++ on Windows, you're going to be locked into one of these tools in general. Now, of course, on Windows, we have Visual Studio. Same type of thing. We can draw our UI elements, drag them on. We have our nice document outline, our events and properties window, and in this case, we're using a WPF app, so we have a nice little XAML viewer down here for typing code. And that's the general process that, whether you're on Xcode or Visual Studio, you'll have to learn the IDE, of course. So that's kind of another hurdle to jump over, especially for developers that might be brand new to this world. All right, now if we're going to walk through the steps of migration here, it would look somewhat like this then. If I have some code on Windows, I of course need to convert that code to Objective-C. From there, I need to convert all of the UI, handle all the events, and more importantly, behind the scenes, invoke the appropriate platform APIs. That right there will be a pretty major rewrite, I think. The syntax conversion, probably not quite as bad, especially if you already have a C-based language, but the UI framework and how it works is definitely going to be a lot different. We're going to need to wire up our event handlers, of course. To do that, we can use the different tools, whether it's Xcode and the interface builder or Visual Studio. And then we're going to want to test a lot. Now, along the way, hopefully you might be using unit testing anyway, and you have that atomic level method testing built in, which will certainly help. But I think even if you get all this right, here's really where the big challenge is. We now have two code bases. And so when Visual Studio comes out with a new version, is the one that your code base is on still going to work? Moving forward, Microsoft has actually done a pretty good job with Visual Studio, the .NET version, doing this. But of course, there's no guarantees. And I've actually had to pop up virtual machines before just to get an old version of an IDE going. And then the same could be said for the Apple side. We're going to have the Xcode. So the problem here is now we're really duplicating code in two places. I have teams with two separate set of skills, and maybe I have a guru that's really good at both. That may be possible, or a couple of them. But, things change, people change jobs, and you just never know long term how are we going to maintain these two code bases. And for me, if I'm a manager, that's the big thing I'm looking at, is how do I deal with this and simplify the overall maintenance. So to kind of wrap this up before I turn it over to JT to do some demos and talk more about the offering that he'll go in and demonstrate a little bit more, it's pretty obvious that Mac continues to grow, although Windows is still dominating, especially in the enterprise market. But we're seeing more and more inroads with Macintosh products, whether it's the MacBooks or the Air or iPod or especially iPad, I think, is becoming very popular there. And the challenges are we have to learn different languages and frameworks, we have different IDEs, and really it's just an overall set of skills that is quite different between the two, and we have these two code bases that means to deal with. So having to introduce kind of the challenges and what the possibilities are, let me turn things over to JT, who's going to do some more demonstrations on how we can solve this problem in a pretty easy manner, actually. So let me turn things over to JT here.
Thank you, Dan. Thanks for giving us a view of some of the challenges around application development and having to support multiple operating systems today. Okay, so I'm going to spend about a half an hour talking to you about how to create Windows and Mac OS X applications, but using a single C++ code base. I'll also be doing a demonstration for you as well. So just to back up, what we're seeing out there is that Windows does dominate the business market. And just like you're telling me in that quick straw poll, most of you have to continue to support Windows today. And no surprise there, Windows does dominate the market. We have to continue to develop applications for it. But I think we're also seeing that Mac is growing, especially in business and in particular in commercial sector. So just a quick statistic. Again, even though Windows is dominant, we're seeing Mac make a lot of inroads, in some cases very large inroads in particular areas. And again, anecdotally, I think we can see a lot more MacBooks in those board meetings, a lot more iPads. So, I think you all recognize that the Mac platform can no longer be ignored, and you have to figure out how to support both. I think you're also understanding some of the challenges that Dan was talking about in looking for a way to do this with a single source code base. So speaking of C++, I'm sure many of you on the call are wondering, well, I'm a C++ developer. Isn't that already the cross-platform solution? We know that C++ is a standard language and library, and we also know that there are C++ toolchains on basically every platform out there. Of course, not every toolchain is created equal, and in particular with the new standard, there are going to be some different levels of implementation around support for the standard with C++ 11, as well as library support, meaning a standard library as well as popular C++ third-party libraries like Boost or Ace, for example. So, yes, C++ was designed to be a cross-platform language and solution, but really, to use just pure C++, you're looking at really basic system-level command line applications. C++ also, of course, can be used for very low-level type of applications. Maybe that's a system-level driver or some type of shared library that other applications are going to use. But I think many of us on the call are being asked to do something more than that, and that is to write visually rich business applications on multiple platforms. And if that's the situation, then the scenario that Dan is running into, I think, is pretty common, and that is today the basic choices are Visual Studio with one framework and one language and one IDE, and Xcode with yet another framework, another language, and another IDE. And ultimately that's leading to maintenance challenges of having to deal with two completely separate code bases moving forward. So if we look at just your typical application architecture and recognizing this is very simplified, but you can generally break it up into three parts. In the top level, you have your presentation layer, and that's how your developers are receiving, your users are receiving information and interacting with your application. Behind that presentation layer is your application logic. This is where you're actually computing some data that based on input from that user or data that's coming from a data access layer from a database. So at a very high level, this is how most applications break down. All three of these layers can be within one binary, or they could also be spread about the internet using the multi-tier approaches. Your presentation layer can be a very small front end that can talk over some type of protocol to application logic in a middle tier, or on a service like Amazon or Azure, and your data access layer can actually live on another layer as well, or some combination. So there's a lot of opportunities and options for how to separate these typical layers and present your application. And I agree with Dan, generally it's good practice to separate as much as you can of your presentation layer and your application logic. In general, that's just going to make your code more portable anyways. So that's something that from a strategy perspective, as you're looking to support multiple platforms and want to maintain a common source code base, separating that UI from your application logic is a good strategy to follow. So Dan presented a scenario of migrating from Windows to Mac that is pretty common today. And what I'd like to present is how could we do this using Embarcadero solutions such as C++ Builder and the FireMonkey framework. So again, a good strategy to start with, it's not a prerequisite, but it's a good strategy to start with, and that is separating your UI and your application logic. So looking at refactoring some code to make that a cleaner separation. Then you would build your UIs with FireMonkey. So you're either going to have to rebuild your UIs in Interface Builder, or an opportunity here is to rebuild them in FireMonkey and still be able to have a Windows application that you can take to Mac. And just like Dan was saying with moving to another framework, you still need to wire up event handlers. So your UI still needs to talk to your application logic. That's a pretty common scenario. And of course, you can't get away from testing. Testing is absolutely critical, whether that's atomic unit testing or full-on testing of the feature set. This is something you have to do whether you're just supporting one platform or many. But I think where the biggest difference is in what we're presenting to you today versus what you're typically faced with using the available tools is that with C++ Builder and FireMonkey, you actually can have Windows and Mac applications with one code base. So the value here is you make this port, but now you're maintaining one code base across both platforms. So the idea is you rebuild your Windows application, you're still developing in Windows, this is where you're doing your development in the C++ Builder IDE, but then with a single click you can target both. You can target Windows and Mac. And you can use one language, C++, you can use one framework, FireMonkey, and you can use one IDE, which is C++ Builder. So I'm just going to do a quick demonstration of what a typical port might look like from a Visual Studio application into C++ Builder. It's actually not that challenging because C++ is a common language between the two of them. So we're going to show you how to take an MFC application, convert that into a C++ Builder application, using FireMonkey, and then sending that, basically porting that to the Mac. So what I'm running here is MacBook Pro, and within the Mac OS, I'm running a VMware instance of Windows 7, and in Windows 7 I am have a Visual Studio instance running, as you see here, as well as a C++ Builder instance. So the example application is really simplified. Single user interface built with MFC. So you can see some MFC code here that creates the form, adds some controls, wire up some event handling, etc. And then has some application logic as well. You can see some common C++ code for dealing with customers. So this is setting up some linked list of customers, managing orders for those customers, and then managing several products or line items for a particular order. So this code is common. This is common C++ code that is wired up into an MFC app right now. So let me go ahead and build this and run it real quick so you can just get an example of what this application looks like. Okay, so now it's finishing the compilation build stage, and we'll launch my application. So again, a really basic app. It's just really two user interface controls that will set up the application logic to load up a bunch of customers and their orders, and then present it in a common output, which in this case is a list box. So let's talk about how to take something like this written in MFC and what it would take to move it to C++ Builder. So here's C++ Builder. What I'm going to do is I'm going to start a new C++ FireMonkey HD application. Okay, so then I'm going to set a couple of captions. This is my customer orders form. Okay, I'm going to make it look like my previous form by resetting the layout, and I'm going to add a button and a list box. Okay, and let's add a list box as well. And so basically, at this point, I've ported at least the presentation aspect of my application. So I just rebuilt visually what my form looked like that I had handwritten in MFC, and I've done that visually with the FireMonkey and C++ Builder Visual Designer. Okay, so let's go ahead and save this to a folder. We'll call that folder Customer Orders, and we're going to go ahead and save everything in there. Okay, so at this point the app will present a form and some buttons, but it doesn't really do much yet. So let's go ahead and start pulling over some of that source code that we're going to need. So what we're going to do is we're going to grab those common classes, which is the customer header and source file, the order header and source file, and the product header and source file. And we're going to copy that into our customer orders folder. Okay, so this is where you have a common C++ source code base between the two of them. Now I'm going to add that to my project, those three files, so that they will get built. Okay. Now, since these were written with MFC, there is a little bit of cleanup that we have to do. For instance, we need to get rid of the MFC header file in each of them. Okay. So now that those are basically compilable, we're going to go back to my form. And we're going to include those headers. Okay, so now we've integrated that source code into this application, but now we need to hook up that application logic to my presentation layer. So the first thing we're going to do is we're going to go back to that Visual Studio application, and in this case it's not the best example of separating UI and application logic, but that may be the case that you're working with as you're moving these things over. What I'm going to do here is I'm going to go ahead and take my on-click button event code, and I'm going to go ahead and bring that over to the C++ Builder project. So where I want this, though, is inside the on-click event. So now this is inside the on-click event. Okay. What I do need to do is a little more cleanup. So CString is an MFC type. C++ Builder has an RTL string called string. So that's what I have to do to modify that type and make that available. And then one last thing that I need to do is copy over my actual list box code. So a couple things I need to do here. One is my class name is different. It's not my customer dialog. In fact, it's tform1. Okay, and then we're going to use a C++ version of the list box, which has some additional elements, the items add, and then lastly I need to change the C string to a string. So to make this all compile, the final thing that I need to do is to move this definition into my header file and add it to my class. Oops, didn't quite capture all of that. And we need a semicolon. And we should be good to go. Let's go ahead and build this and run it. Hopefully no errors or warnings. Okay, so we basically have gone through the process of taking an existing MFC form and some application logic and ported that now to FireMonkey. So now, if I were doing this traditionally, I would be trying to move this over to Xcode and add some Objective-C and do a new UI. So, you know, I would be spending the time over there and then starting to have two separate code bases. But here, what I'm going to show you now is I have one code base that I've already built a Windows app with. And now I'm going to go ahead and target OS X. So the way we do that in C++ Builder is we select a platform. So platforms available right now are OS X and 32-bit Windows. And to port this to OS X, all I have to do is build it. So running on OS X, I have a little daemon called PA Server. It's just an application that runs on my target and communicates, or the IDE can communicate with it. It's going to build the application using a cross compiler. So it's going to build a native Mac OS X executable. It's going to copy that over and any other required files onto my Mac, and it's going to go ahead and launch it for me. It could also launch a debugger for me so that I can connect and do remote debugging as well. So the porting effort, like we said before, is just a single click. You basically rebuild and it deploys and it will be running on the Mac OS. Okay, so now we're in my Mac OS. Like I said, it's deployed that for me. One thing you may notice is that it's actually taken on the look and feel of a Mac app. It's got the common menu bar up here. It's got the common application area, but all the basic UI and application logic all work exactly the same across both platforms with the exact same set of source code. So that is just a basic demo I wanted to share with you to give you an idea how quickly and easily you can get to a shared source code base between Windows and Mac. You're going to have to expend the effort anyways to get to a new framework, but now you don't have to learn a new language and a new IDE, and you get to maintain one code base with FireMonkey and C++ Builder. So I'm going to spend a few minutes talking a little bit more about FireMonkey and what it can do as a framework. So FireMonkey is actually a full application platform, meaning it's not just about drawing widgets. It also includes support for services and data access and pretty much everything you'd come to expect from a standard application platform. What it does differently, though, in the drawing area in particular is, well, first of all, it compiles to native binaries on Windows and Mac. So these are cross-compiled, in the case of Windows, local compiled, but these are cross-compiled applications that are native binaries. And all the application logic, database, and animation code are still run inside a CPU, in this case an Intel CPU. But the UI, the graphics, and the effects, which are part of FireMonkey, are all GPU powered. So the UI is actually built using a set of vector-drawn controls that are running inside a hardware-accelerated context, which is DirectX or Direct3D on Windows and OpenGL on Mac. So even though they're presenting the same controls, they're drawn using different libraries that give us hardware-accelerated UIs. And the advantage there is that we can start doing more with the UIs. We can mix and match 2D and 3D, but we don't tax the CPU. We can leave that for our application logic and other things like that. So the types of applications or forms you can build with FireMonkey are what we call HD and 3D forms. So again, these are all very high-performance, GPU-powered, scalable vector UIs. This really allows you to take advantage of the maximum resolution on any device. And in a world where we're starting to get to so many different types of form factors and different types of pixel density on different devices, this is going to become an important feature. FireMonkey provides hundreds of visual UI components, so pretty much any type of UI component you think you need, FireMonkey has it. But it also provides, now since it's running in the GPU, hardware-based lighting, textures, and animation. It also provides a style engine so you can control the UI look and feel. And now this is a library that we think we can start using to build some of these futuristic, at least futuristic 10 years ago, some of these interfaces we've seen in movies like Minority Report or Avatar or Mission Impossible, where they just have these really cool looking futuristic UIs. This is really something that is a capability and a possibility using FireMonkey and the GPU to render those. So by default, FireMonkey is going to give you a style that is the native user interface look and feel. So again, these are not native widgets, but they're drawn to look and act like native widgets on those platforms. What they are instead, again, is GPU-powered vector scalable UIs. But on Windows, it can look like a Windows app. On Mac, it can look like a Mac app. Or you can do something that's completely custom for your enterprise and make it look the same way across multiple platforms. But in addition to building or providing UI components, another feature of FireMonkey is what we call image effects. This is an effects package that has basically we've written GPU shaders to provide effects that are like Photoshop effects, but they're done in real time and they tax 0% of the CPU. So this is all done in the GPU. These are very powerful coprocessors that we're able to take advantage of. So you can do simultaneous multiple effects. In this case, all these effects are running on 9 different images, all in real time without touching the CPU at all. But building business applications isn't just about building UIs. It's also about visualizing data. Ultimately, we need to present business data to our users, and this is an opportunity to think about new ways to present data rather than just your typical grid or list box. One of those ways that we provide this is we provide a mechanism to dynamically map data to a control. And so, of course, this supports scenarios where you want to take a table and present that in a grid, or if you want to take a text field and present that in a text control. But one thing that light bindings can do is it can take advantage of the runtime type identification available in the runtime library underneath C++ Builder and allow you to map properties and data together. So here's an example. This is a map of the world, and what you're seeing here is data that's helping you visualize some type of information about these countries. In this case, it's a population graph, and this can change over time. This is data being fed out of a database. But the way they present this data, rather than just a bunch of numbers, is they're extruding the size of the country out, so that the higher it is, you get a visual representation of, oh, the population is higher in comparison to some of these other surrounding countries. So this is a powerful way to present data. And using live bindings, it's actually really simple. I basically would have a 3D control that is an arc path surrounding that country. I would take that population data out of my database and I would map that to the height property of that extruded path. So really, without writing any code, I'm able to iterate through a bunch of data over time and have my 3D view of this world be updated in real time to show me the relative size of population over time of these countries. So that's an example of how live bindings can be used. It's a very dynamic way to not only map data to traditional UI controls, but also map it to new ways to visualize data. And of course, you need to get this data from somewhere. Most enterprises are running some type of enterprise database, whether that's Oracle or MS SQL or SQL Server or Sybase or Interbase. We provide built-in database drivers for all these popular databases, and we have an actual data access layer as well. We talked a little bit about that format of an application architecture. So FireMonkey does have a data access layer that gives you common access across all these different types of databases. In addition, it allows you to connect to and utilize Amazon and Azure cloud services. So you can either use a service or you can deploy an application to one of these cloud solutions as well. So for example, I could take some of my application logic and I can build that as an application to run inside Azure or Amazon EC2. And I can have a portion of my client-side code presenting the information, but then talking to the service that's running out there on that cloud service, which may talk to another tier that's talking to a database. And this is all done using common and standard technologies, whether that's SOAP or JSON and REST or other types of transmission protocols. But we've also built and provided pre-built connectors so that you can take these types of data, what we call data snap applications, and present these to all the supported mobile platforms out there as well. So last week we published some information about where we're taking C++, and I just want to share that with you at a high level. I'll also give you a link to that roadmap article so you can see what we're doing with C++. Up to now, we've taken C++ and we've provided the FireMonkey framework, which can allow you to build a single source code base Windows and Mac OS X app on Intel architecture. In the future, we're delivering a brand new compiler based on open source Clang and LLVM. We've actually ported some of our extensions that allow you to do this visual design and take advantage of this rich RTTI using C++ and also take advantage of this framework. So that's available now on Windows and Mac, as you just saw. With the next release, we're going to be delivering a 64-bit compiler for Windows utilizing this new compiler. In addition, we're also going to be starting to target new processor architectures. So first on the list is ARM and iOS as the OS. So we'll be supporting FireMonkey on iOS using C++. And following that, we will deliver an Android version of that as well. So just like you saw me take a Windows application today and with a single click be able to port that application to Mac, what you're going to get here in the near future is the ability to build an iOS application with C++, pure C++, and with a single click port that to Android and have a single source code base between both of those major mobile platforms as well. So the ultimate aim of FireMonkey is to allow you to have a single source code base across all these platforms. You may have to have some different form code depending on the devices that you're supporting, but the bulk of your code, that application logic, your interaction with the application stack, and standard C++ are all going to be fully supported. A little bit more about what we're doing on the mobile side is we're also going to be extending it to be mobile optimized. So we'll be providing access to common sensors like your camera, GPS, NFC radios, for example, standard mobile services like advertising, payment APIs, and location, giving designer support to deal with multiple form factors and also runtime support to deal with that as well. But all this will be is Windows-based development. You saw the IDE running in Windows, and it's all going to be done through cross-compiling. And in the mobile platforms, of course, there's additional steps. In addition to building the binary, we also have to package and sign that. So that part of the workflow will be automated packaging and signing, deployment onto a simulator, emulator, or device, and then connecting up debuggers for remote debugging on all those platforms. So I'd like to end the session today by announcing a special offer. What we're offering is the ability to buy C++ Builder XE2 and a maintenance bundle. And if you partake in this special offer, you get an additional 20% savings on your C++ Builder license today. But the maintenance portion of that, which is part of this bundle, gives you up to 1 year of major version upgrades and support. So as we start delivering some of these features around mobile support in particular, iOS and Android, you're going to get those features available to you when they're available, as soon as they're available. Additionally, for those who participate in the special offer, we're providing priority preview access of our new compiler, starting with the 64-bit Windows compiler. So again, this is an open source Clang and LLVM based compiler with our extensions that is going to have industry-leading standard C++11 and C99 language support, give you full support for FireMonkey and VCL on Windows, and allow you to more easily port your apps to all these platforms. So we'll go ahead and jump into a Q&A session. If you have any questions for myself or Dan, go ahead and enter them into the question field. And I'll go ahead and leave this slide up, which shows you the link to the information on the special offer, as well as a link to the actual published roadmap on our developer network site. So thank you for your time, and I look forward to your questions.